We were discussing about question bank, right? We were discussing about question bank, am I right?
Yes, sir.
So have you gone through all the questions till now, whatever discussed?
Yes, sir.
క్వశ్చన్ ఇటు జస్ట్ ట్విస్ట్ చేస్తారు అంతే. ఓకే, ట్విస్ట్ చేస్తారు. ఆ ట్విస్టింగ్ కి రిలేటెడ్ గా కరెక్ట్ గా ఆన్సర్ ఇవ్వడం, అది ఒక్కటే పాయింట్ మీరు ఐడెంటిఫై చేసుకోవాలి. ఓకే, మిగతాదంతా సేమ్ అదే స్టోరీ. ఎన్ టైప్, పీ టైప్ కానీ, అటు క్వాంటమ్ మెకానిక్స్ లో కానీ ఏదైనా సరే. సో మన క్లాస్ లో డిస్కస్ చేసిన కంటెంట్సే ఇటు ఇటు చేసి చేస్తారు. సో రిమైనింగ్ ఎవ్రీథింగ్ విల్ బి సేమ్. దట్ ఈస్ వాట్ ద క్రైటీరియా ఈస్. ఓకే, సో ప్రాబ్లమ్స్ అవి చేసుకుంటున్నారా?
Yes, sir.
చేశారా?
Sir.
చూపిస్తారా ఒకసారి వీడియో ఆన్ చేసి ఏం చేశారో చూద్దాం. అసలు జస్ట్ మామూలు
Okay.
అటే వచ్చారు. ఎంత నెంబర్ ఎంతమ్మా?
D8, sir.
ఓకే, D8 ఎక్కడున్నావు? ఎక్కడ కనపట్లేదు D8. మిగతా వాళ్ళు ఎవరు చేయట్లేదా బాబు? అంతమంది జాయిన్ అయ్యారు, 45 మెంబర్స్ ఉన్నారు ఇప్పటిదాకా. ఎవ్వరు ఒక్క వీడియో ఆన్ చేయరు. ఏం లెక్క, అసలు ఏం చేస్తున్నారో చెప్పరు. ఎక్కడ ఉన్నావమ్మా? వచ్చావు D8. చూపించు తల్లి ఒక్కసారి, ఏం చేసావు అసలు?
1 minute, sir.
ఎగ్జామ్ షెడ్యూల్ వచ్చింది చూసారా? CIE 1.
Yes, sir.
ఎప్పటి నుంచి?
22nd.
22nd.
మీ ఫిజిక్స్ ఎప్పుడుంది? ఇంజనీరింగ్ ఫిజిక్స్ ఎప్పుడుందమ్మా? ఆ?
25th, sir.
25th ఎగ్జామ్, రైట్. అంటే 25th వరకు మీరు 2.5 మాడ్యూల్స్ రెడీగా ఉండాలి, అంతే కదా?
Yes, sir.
ఫస్ట్ మాడ్యూల్ ఏంట్రా బాబు? D9
Quantum mechanics, sir.
వెరీ గుడ్. ఏంటి ఒక్కటే కరెక్ట్ క్లారిటీ రావట్లేదు? ఒకటే కనబడుతుంది, మిగతావి ఓకే. ఫోల్డ్ చేసావా? బ్యాక్ ఫోల్డ్.
Sir.
ఓకే, రెండే కనపడ్డాయి, 2 పేజీలే కనపడ్డాయి. ఓకే అమ్మా, వెరీ గుడ్. ఎస్. సో మిగతా వాళ్ళు ఎవరు చేయలేదా? ఒక D8 ఒక్కళ్ళే చూపించారు. D9 చూపించినానా? ఉండు. D9 ఏంటిది? లాగర్థం ఏదో రాసావు, 2 × 2/kbit. అన్ని ప్రాబ్లమ్స్ చేసావా?
చేసా సార్.
వెరీ గుడ్. D9 వెరీ గుడ్. ఓకే, ఆ గ్యాప్ ఎందుకు వదిలేసావు? రాలేదా లెక్క?
రాలేదు సార్, అంటే చేయాలి సార్. అది అంటే వచ్చింది, మీరు చెప్పారు సార్, చేయాలి సార్ అది.
ఓకే, డన్
అంతే సార్.
ఓకే, D9 నెక్స్ట్. వచ్చేస్తారులేండి ఇక ఆన్లైన్ ఆఫ్లైన్కి. ఎప్పటి నుంచి ఆఫ్లైన్?
7th అన్నాడు సార్, షూర్ కదా తెలియదు.
మళ్ళీ అక్కడ వేవరింగ్, మళ్ళా ఇంకా ఇంట్లో కూర్చుందామనే.
అంటే ప్రతిసారి ఏదో అనౌన్స్మెంట్ ఇచ్చి మళ్ళీ కాదని చెప్తున్నారు.
ఓకే, నెక్స్ట్ ఎవరు వేసారు చూపించండి. ఎవరు? ఇద్దరే చూపించారు, D8 D9. ఏమయ్యా అంతమంది ఉన్నారు క్లాస్లో? 51 మంది ఉన్నారు, ఇద్దరేనా చూపించారు? E3 ఎప్పుడు క్లాస్కి రాడు, కానీ చూపించడం మాత్రం చూపించినట్టున్నారు. కనపడట్లేదు, అంతేనా? E3 రెగ్యులర్ గానే ఉన్నాడు. వెరీ గుడ్, వెరీ గుడ్. ఎవరో కానీ E3 రెగ్యులర్ గా ఉన్నారు. సారీ బాబు, మీరు రెగ్యులర్ గానే ఉన్నారు. నెక్స్ట్, ఓన్లీ D8, D9, E3, F0. F0 is trying to show something. Yeah, show me. ఓకే, అందులో క్వశ్చన్ బ్యాంక్ లో చాలా ప్రాబ్లమ్స్ ఉన్నాయి కదా, మీరు ఏంటి 1, 2 చూపిస్తున్నారు? 2 లెక్కలు చేసి చూపించేస్తున్నారు అంతేనా? F0 కెమెరా ఆఫ్ అయిపోయింది. నెక్స్ట్, ఓన్లీ 4 మెంబర్స్. ఏమో ఇంతమంది ఉండి ఓన్లీ 4 మెంబర్సా? ఎస్, G1 సిఆరా? బాబు సిఆరా?
నో సార్.
ఈవె బ్లాక్ కనపడుతుంది పక్కన కెమెరా, ఇది షేడింగ్ వస్తుందా? ఓకే, డైవర్జెన్స్. అరే బాబు, నేను అడిగింది మాడ్యూల్ 2 మాడ్యూల్ 1 క్వశ్చన్స్ రా నాయన. క్వశ్చన్ బ్యాంక్ డిస్కస్ చేసిన దాంట్లో ప్రాబ్లమ్స్ గురించి అడిగాను. ఓకే, గుడ్, వెరీ గుడ్, యు డిడ్ ఇట్.
లైన్ గా ఉన్నాయి సార్ అన్ని
లైన్ గా ఉన్నాయా? ఓకే ఓకే ఓకే, రైట్, నో ప్రాబ్లం, నో ప్రాబ్లం. మళ్ళీ ఆఫ్లైన్లో వచ్చినప్పుడు మళ్ళీ చూస్తాను నేను, ఇబ్బంది ఏం లేదు. H1, రైట్. ఓకే, రైట్, మళ్ళీ వెరిఫై చేస్తాను. ఈ నెంబర్స్ కాకుండా మిగతావన్నీ వెరిఫై చేస్తాం మళ్ళీ ఆఫ్లైన్లో వచ్చినప్పుడు. D8, D9, E3, F0, G1, H1 వీళ్ళు తప్ప మిగతా వాళ్ళందరూ వెరిఫై చేస్తాం. ఓకేనా? చేయని వాళ్ళు ఉంటే రెడీ చేసుకోండి మళ్ళా. నెక్స్ట్, సో let us go to the next module, that is what is that next module? Previous 2 modules అయినాయి కదా, ఒకటి క్వాంటమ్ మెకానిక్స్, ఇంకోటి సెమీకండక్టర్స్, సాలిడ్స్ అండ్ సెమీకండక్టర్స్.
Lasers.
Yes, lasers and optical fibers. So let us discuss some of the questions that are there, that are present in the question bank. Okay, so see here, I am sharing the screen. Yes, sharing the screen.
Yes, sir.
సో మీరు మండే కనుక వస్తే డైరెక్ట్ గా మీకు ల్యాబ్ కూడా ఉంటుంది. ఆ రోజు మీరు ల్యాబ్ చేయాల్సింది ఉంటాయి, వేరే ఎక్స్పెరిమెంట్. ఓకే, మేబీ యూ నీడ్ టు డూ ఎనర్జీ గ్యాప్ ఆఫ్ ఎ సెమీ కండక్టర్. ఓకే,
Okay, sir.
yes, let us go for the module 3, that is lasers and fiber optics. Yeah, see the first question, part A, analytical questions. Find the relative population of the 2 states in a ruby laser that produces a light beam of wavelength 6943 angstroms. Wait, let us discuss first the theoretical questions and then we'll go for the problems. Yeah, so let us go for the part B, long answer questions. First we'll discuss the questions and then we'll see about the problems or the numericals that are associated with that. Yeah, so the first question is, illustrate the characteristics of laser. Illustrate the characteristics of laser and highlight the phenomena of lasing action required for the production of laser light. So illustrate the characteristics of laser. So what are the characteristics of laser? Anybody having some idea behind this?
Highly monochromatic.
Yes, first one is highly monochromatic. You need to explain what is highly monochromatic. Okay, first one is highly monochromatic,
High directionality.
and
Highly coherent.
very good.
High brightness. High brightness, sir.
High brightness.
Intensity.
High intensity, brightness. Okay, very good. So these are the characteristics of lasers. So beta, you need to explain each and every characteristic. ప్రతి ఒక్క characteristic మీరు ఏం చేయాలి? Explain చేయాలి. Okay, so monochromatic you can explain, no problem. Okay, brightness also you can explain. So but is by giving an expression called divergent expression, that is R2 minus R1 by 2 into D2 minus D1, the difference of divergent beams and the radius. And the other foremost important one is the coherence. Okay, so the coherence is an essential property or essential characteristic for the lasing action. Okay, Coherence is essential property for laser, right? So how many types of coherence are there? There are two types of coherence. Remember that there are how many types of coherence? Two types of coherence. What are those? One is the spatial coherence and other is the
Temporal.
temporal coherence. Okay, what is the spatial coherence and other is the temporal coherence. So what is the difference between these two types of coherence? Spatial coherence and temporal coherence. Any idea? What is spatial coherence? Spatial coherence and temporal coherence.
The predictable correlation of amplitude and phase at a point
Can you see on the
on
screen?
wave train with respect to another point in second
Can
wave.
you see on the screen?
Yes, sir.
Oh, this is shared. No. Right. Yes. So coherence, right? So coherence is one of the unique properties of laser light. It arises from the stimulated emission process. Since a common stimulus triggers the emission events which provide the amplified light. So the emitted photons are in step and have a definite phase relationship to each other. That means two waves are said to be coherent if they emit a light with a constant phase difference. So that type of that is what we explain about the coherence, right? So what I'm meaning to tell you is there are how many types of coherence? One is a spatial coherence, and another is a temporal coherence. So the difference between spatial and temporal coherence is, see, so this spatial and temporal coherence, okay, so this spatial and temporal coherence have the significance in terms of time, okay, in terms of time, okay. So spatial coherence is independent of time, and whereas temporal coherence is dependent of time, okay. Within a time span, within a very time span, the light that is emitted, okay, the light that is emitted will be calculated in terms of time process. So that is one of the essential difference we can tell between the spatial and temporal, right? So these are the monochromacity. So directionality is what we are writing it as delta theta is equals to R2 minus R1 by D2 minus D1, and high intensity and other is okay. So these are some of the characteristics of laser light, okay. Yes. So next question is, explain the phenomena of absorption and pumping mechanism related to excitation of atoms from lower to higher energy states. So how do you differentiate? What is the phenomena of absorption and pumping? see, to explain the working principle of laser, we need to undergo three processes. To explain the working principle of laser, we need to undergo three processes. One is the what is that working principle? One is the absorption process, another is the stimulated, other is the spontaneous. Absorption spontaneous and other is stimulated, right? So at the absorption process, what is happening? At the ground state, we have ground state. In the ground state, we have some atoms. When an energy of h nu radiation is allowed to fall on the atoms on the ground state, the atom absorbs the incident photon and jumps to the excited state. Okay, so that type of process is what we are calling it as the absorption. Okay, so how explore the phenomena of absorption? That is what we talk about absorption. What about the pumping mechanism? How do you pump? What is a pumping mechanism? What do you mean by pumping? How many types of pumpings are there? What do you mean by pumping? Pumping ante entandi?
Process of sending atoms from lower energy state to higher energy state, sir.
కాదమ్మా, నేను పంపింగ్ అడుగుతున్నాను. పంపింగ్ how many, what do you mean by pumping? How many mechanisms are there for pumping? Pumping mechanism, what do you mean by pumping?
So stimulated emission is
Pumping antera babu. See, pumping can be done in how many ways? Yes, pumping can be done in how many ways? పంపింగ్ అండి, పంపింగ్ ఎట్లా చేస్తారు? ఒక రూబీ లేజర్ తీసుకున్నారు, దానికి రాడ్ ఒకటి వౌండ్ చేశారు. సో వాట్ ఈస్ ద పంపింగ్? సో టు మెయింటైన్, యూ పీపుల్ చదవట్లేదు మీరు, చదవండి, రైట్? సో టు మెయింటైన్ పాపులేషన్ ఇన్వర్షన్, ఓకే, టు మెయింటైన్ పాపులేషన్ ఇన్వర్షన్, okay, to maintain population inversion, atoms have to be see, to maintain population inversion, atoms have to be raised, okay, continuously to which state? To the excited state. Okay, atoms are to be raised continuously to the excited state. Okay, so it requires energy, right? It requires energy to be supplied to the system. It requires some energy. Okay, so this process of supplying energy, okay, this process of supplying energy to the medium, okay, to the medium with a view of transferring energy, is what we call it as pumping. Okay, so how many types of pumpings are there? There are 6 types of pumpings. What is that? Optical pumping, electrical pumping, okay, atom collision, atom interaction or atom collision, okay, so direct conversion, chemical reaction, and inversion pumping. So these are the different types of pumping. So pumping is nothing but giving energy, okay. So these are what we explained for these are what we explained to understand the different types of pumping mechanisms. Okay, clear?
Yes, sir.
So strictly, how can you tell, how can you define the term pumping? I think I have given the notes for you this. Did I give the notes for lasers?
No, sir, we only have the PowerPoint presentation.
I think I have sent the notes. Notes ఇచ్చానమ్మా?
No, sir.
Notes ఇచ్చాను. ఎవరది? Wait, I'll check my phone. I have sent that. బాబు, సిఆర్కి పంపించినట్టున్నా నేను నోట్స్, లేజర్స్. సిఆర్ ఉన్నారా?
ఎస్ సార్. సార్ ఓన్లీ 2
పంపించాను నోట్స్
పంపించాను
మీకు.
సార్. లేదు సార్, ఓన్లీ మాడ్యూల్ 1 మాడ్యూల్ 2 పంపారు సార్. మాడ్యూల్ 3
మెయిల్
పంపలేదు.
కాదు, వాట్సాప్ చేశాను.
ఎస్ సార్. ఓకే సార్, చూస్తా.
ఓకే సార్ చూస్తానంటే ఏంటవయ్యా, రోజు పంపించాను కదా సాటర్డే నాడు. మీరు ఫ్రైడే క్లాస్కి అడిగారు, నేను మర్చిపోయాను ఈవినింగ్ పంపడము. మళ్ళీ నాకు నువ్వు సాటర్డే నాడు వాట్సాప్ పెట్టావు. ఏం పేరు రా బాబు నీది?
ప్రణవ్ సార్. ఎస్ సార్, పంపించారు సార్. పంపించాను నేను
పంపాలి
గ్రూప్లో
ఎట్లా
సార్.
నాన్న, పంపాలి కదా స్టూడెంట్స్ కి.
పంపా సార్ నేను.
మీ గ్రూప్ లో పెట్టలేదా?
పెట్టా సార్.
ఇప్పుడు పెట్టావా?
లేదు సార్, బిఫోరే పెట్టా సార్. కావాలంటే చూడండి సార్, అడగమని.
నేను చూస్తాను, మీ ఫ్రెండ్స్ లేదంటున్నారు కదా మీ క్లాస్మేట్స్.
పంపా సార్.
చూడండి అమ్మా, పంపారు.
చెక్
లేకపోతే
చేసుకోలేదు
నన్ను
సార్.
పంపితే నేను
ఇప్పుడు
చెప్తాను. నేను
చూసాను
పంపుతాను మళ్ళీ కావాలంటే.
సార్, చెక్ చేసుకున్నాను సార్ ఇప్పుడు.
పంపే ఉంటాడు, ఎందుకంటే ఆ రోజు
Sorry, sir.
అడిగాడు. మీరు చెక్ చేసుకోండి, కరెక్ట్ గా ప్రింట్అవుట్ తీసుకోండి. నోట్స్ ప్రింట్అవుట్ తీసుకోవడమా లేకపోతే రాసుకోవడమా చేయండి. సో ద ప్రాసెస్ ఆఫ్ సప్లైయింగ్ ఎనర్జీ టు ద మీడియం, ఓకే, ద ప్రాసెస్ ఆఫ్ సప్లైయింగ్ ఎనర్జీ టు ద మీడియం with a view to transfer it into a state of population inversion, okay, is what we call it as pumping. We call it as pumping. Simply the process of achieving population inversion. The process of achieving population inversion is called pumping. So commonly used pumping mechanisms are, so first one is optical pumping, electrical discharge, atom-atom interaction, okay, direct conversion, chemical reaction, injection current. So these are some of the different types of pumping mechanisms. Okay, so that is what we need to explore the phenomena of absorption and pumping mechanism related to excitation of atoms, okay, from lower energy state to higher energy states. Okay, so next question, demonstrate the construction and working of Ruby laser in detail with the help of neat suitable diagram. Right, so I think you can see the diagram meeku unda?
ఉంది సార్.
Ruby laser. Okay, so Ruby laser ఒకసారి ఓపెన్ చేయండి. Ruby laser. See, we have the laser we have the Ruby laser, right? So we have a Ruby rod, which is a combination of aluminum oxide, Al2O3 plus Cr2O3. So this Ruby rod is surrounded by a lamp, okay, so which is wound in the form of helical shape, okay, so which is also used as a source of pumping. Right? So when we give certain energy, so what happens? The light flashes out. So this flash lamp is what we are calling it as the optical pumping. So that is what the mechanism we observe is called the optical pumping. The flash lamp generates some energy. So due to this energy, the chromium ions get excited. Okay, so when we explain the lasing action, it will require the components of lasers, right? The components of lasers are nothing but the active medium, pumping mechanism, reflecting mirrors. Okay, so all these components will comprise comprise in the Ruby laser, right? So the active medium is the chromium ions. If the optical the pumping mechanism involved is the optical pumping. Okay, so from there the light get reflected from the reflecting mirrors, okay, which will generate a wavelength of around 6000 angstroms. Okay, so that is what we need to explain with the help of a diagram. Okay, with the help of diagram that is called Ruby laser, right? Okay, so what is the active material there? The active material Ruby crystal in the form of a rod, a mixture of Al2O3 plus Cr2O3. Okay, so resonating cavity, so that is also one of the active component of a laser. Resonating cavity, as I told you, a fully reflecting surface at the left end of the Ruby crystal and partially reflecting end at the right side of the Ruby crystal, okay, are to be arranged. Then the pumping mechanism, the optical pumping, right? So we need to explain about the energy levels. Okay, so that is the metastable state and population inversion, and where we get the stimulated emission and the Ruby laser light will be get emitted out. So that is what we need to explain in case of this construction and working of ruby laser. Okay. Similarly, if you go for the fourth question, that is narrate the construction and working of helium neon gaseous laser in detail with the help of neat diagram. So helium neon laser, which is a combination. So if you need, which is a combination of what? Helium neon is taken in what ratio? Helium neon is taken in what ratio? 10 is to
10 is
1.
to 1, sir.
10 is to 1.
10 is to 2.
1, sir.
10 is to 1. Okay, see, let me tell you what are the drawbacks of the ruby laser. There are certain drawbacks for the ruby laser, right? What are the drawbacks? See, if you can see in your notes, you can see the drawbacks of the ruby laser are the laser requires high pumping power to achieve population inversion. Okay, it is a pulsed laser. The output we get from the ruby laser is a pulsed laser. So what are the applications of ruby laser? So distance measurement using pulse echo technique. Okay, this is what we write it as application. Pulsed holography for drilling high quality holes. For drilling high quality holes, we use the ruby laser, right? Ruby laser, and used in general research applications such as plasma production and fluorescence spectroscopy. So these are some of the applications. So these are some of the applications which you need to explain, for the ruby lasing action. Okay, so these are some of the applications, right? So that will end up with the ruby laser. Now, if you go for the next question, that is what this demonstrate the construction and working of helium neon laser. The mixture of helium neon is taken in the ratio of 10 is to 1. Okay, and we need to see some energy levels. So we need to see some energy levels, right? So the energy levels, the transition state from the higher energy level to the lower energy level, in the sense metastable states. Okay, we need to explain different transition states, right? Am I right?
Yes, sir.
So from where the transition takes place generally the transition, see, helium neon excites, right? So we are taking the ratio of helium neon as 10 is to 1. Okay, so at excited states, that is between the states, that is E6 to E5, there is no transition. E6 to E5, there is no transition of energy. Whereas from E6 to E3, there is a transition of energy around how much? 6328 angstroms. Okay, 6328 angstroms. That means the transition levels of energy are to be discussed. The transmitted energy levels are to be discussed from different transition states, different transition energy states at the excited state. That is, we need to, we are discussing about 6 states here. We wrote about 6 states. One is E1, E2, E3, E4, E5, and E6. So we need to explain the transition between 2 energy states, that E6 to E4 and E6 to E3 and E5, from E6 to E5. So when E6 to E5, it is around 3.36 micrometers. Why there is a less energy between E6 to E5? Can anybody explain? Can anybody tell why there is a less amount of energy between E6 to E5? E6 నుంచి E5 కి ఎందుకు ఎనర్జీ తక్కువ వచ్చింది? What is the essential condition to obtain the lasing action? The essential conditions to obtain lasing action is a population inversion and optical pumping mechanisms. So pumping and population inversion. Okay. So the transitions, what I'm asking is why the transition between E6 to E5 is very less. Why the energy radiated is very less when compared to the energy radiated between E6 to E4, where the transition between E6 to E4 is approximated to be 6,328 angstrom, where we get maximum lasing action. Why? Anybody can answer the question? చెప్పాలి బాబు. Yes, anybody who can answer? See, I'll tell you normally, right? Energy levels and helium atoms excited levels spend sufficiently large amount of time. Okay, they spend large amount of time, okay, before getting de-excited, right? So some of the excited states of neon can correspond approximately to the same energy of excited levels, that is F2 and F3. Okay, thus when helium atoms collides with the F2 and F3 levels, okay, they collide with neon atoms. They collide with the neon atoms at the ground level E1. Okay, so there what happens? An exchange of energy takes place. Okay, this results in excitation of neon atoms to the levels E4 and E6 and de-excitation of helium atoms to the ground level F1. Because of long life times of the atoms in the levels F2 and F3, the process of energy transfer has a high probability. Okay, thus what happens? The discharge through the gas mixture continuously populates the neon atoms in the excited state energy. Okay, the excited state energy levels E4 and E6. So this helps to create a state of population inversion between the levels E4 and E6 and to the lower energy level, that is E3 and E5. So the various transitions, that is what we told, that various transitions will occur between E6 to E5 and E6 to E4. So you can see the figure there. Can you see the figure? And the radiated energy is around 6328 angstroms. So that is what you need to explain. So specific frequency selections may be employed. Specific frequencies of that incident radiation is to be taken there. Okay. So this is what we need to explain for the helium neon laser. So what are the applications of helium neon laser? Very widely and used laboratories for all interferometric experiments. Okay. And helium neon scanners have also been used for optical character recognition, used in 3D recording of objects called holography. Okay, so these are some of the applications we use for this helium neon laser, right? So the next question, so the same question, that is narrate the construction and working of helium neon laser. That is what this one there. Right. So next question is explain the importance of lasers in various medical fields like medicine, science, etc. by giving the application. So you need to explain how the lasers are used in industries, how the lasers are used in medicine, and how the lasers are used in sciences and all. Okay. So this is what the criteria you need to follow. Okay. So next question, discuss in detail the phenomena of spontaneous emission and stimulated emission. Discuss in detail the phenomena of spontaneous emission and stimulated emission. So you know what is spontaneous emission, right? So the atom that is residing at the excited state spontaneously comes down to the lower energy state by releasing only one atom, by releasing only one photon, right? So whereas in case of stimulated emission, the atoms that are residing at the excited state need to get stimulated. How they are getting stimulated? Some energy needs to impinge on the atoms in the excited state. When the energy starts impinging on the atom in the excited state, so the atoms will try to move to the ground state by releasing two photons, where we can assume some sort of increased energy, where we can observe some sort of increased radiation. Okay, in case of stimulated emission, that is the reason why stimulated radiation became the essential cause for the lasing action. That is what, when we speak about lasers, we tell that light amplification by stimulated emission of radiation. That is what the reason is. Okay. So the next question, the seventh question, what do you mean by population inversion, and explain it using 3 energy level diagram. Also discuss why population inversion is essential for lasing action. So for population inversion, why population inversion is essential for lasing action is what to be discussed. Okay. So any doubts?
No, sir.
చూసుకుంటారా నోట్స్ ఒకసారి?
Yes, sir.
ఏమి చూసుకుంటున్నారా లేదా?
Yes, sir.
Okay. Next. So what do you mean by population inversion? Explain it using 3 energy level diagram. Also discuss why population inversion is essential for lasing action. So the same you need to explain what is the principle, what is population inversion and all. So next is illustrate the purpose of active medium and optical resonator in a laser system. So you need to explain the components of laser. You need to explain the components of laser. What are the components of laser? Essential components of laser. Laser active components ఏమున్నాయండి? Lasers కి components ఏముంటాయి? Babu, what are the components of laser? What are the components of laser? Laser components ఏంటండి? What are the components of laser?
Gain medium or
Huh? What are the components of laser చెప్పాలి?
Optical cavity.
Next.
Active medium.
ఇంకా
100% reflecting mirror, partial reflecting mirror. Laser beam.
ఇంకా resonator cavity, active medium, pumping. Next. Resonator cavity లో ఏముంటాయి? Resonator cavity లో ఏముంటాయి? Resonator cavity లో ఏముంటాయి బాబు? Partially reflecting mirrors. What will be there? Partially reflecting mirrors. Okay, so these are the components of laser. Good. Okay, so these are the components of laser. Okay, so that is what we need to explain. What do you mean by population inversion? Yeah, so illustrate the purpose of active medium and optical resonator laser system. Active medium ఏం చేస్తుంది? What is the function of active medium? What is the function of active medium? యాక్టివ్ మీడియం ఏం చేస్తుందండి? యాక్టివ్ ఎనర్జీ లెవెల్స్ ని యాక్టివేట్ చేస్తుంది కదా. యాక్టివ్ అనేది రూబీ రాడ్ ఉంది. రూబీ రాడ్ యాక్టివ్ మీడియం ఏంటిది? క్రోమియం 3 అయాన్స్. సో Cr3+ అయాన్స్ ని యాక్టివ్ మీడియం గా తీసుకొని పంప్ చేసినప్పుడు వాటిని ఏమవుతుంది? ఎనర్జీ లెవెల్స్ యాక్టివేట్ అవుతాయి. దట్ ఈస్ ద పర్పస్ ఆఫ్ యూజింగ్ active medium, right? So that is what all you need to explain. Okay, so how light amplification is achieved in laser system? So light amplification etla jarugutundi? By stimulated emission. Okay, that is what all you need to explain about this one. So amplification is achieved. Explain the pumping process involved in laser emission. Also discuss different pumping mechanisms. Okay, explain the pumping process involved in laser emission. So pumping process etla jarugutunnadi laser emission lo cheppali, explain cheyali. So you need to explain what is pumping there, and then you need to understand how many types of mechanisms are there in laser pumping action. Okay, so that is the criteria. So remaining questions we'll discuss tomorrow. Okay, so from 11th onwards we'll discuss tomorrow and after tomorrow, and then when you come to the offline class, then we'll start the next content. Okay.